Okay, this is the third video for the day. Remember, this is all review from grade 11. So we're going to do cyclic structures now. Now, the other stuff we did was called aliphatics. These are cyclic because there's no beginning or end. These are the 1, 2, 3, 4, 5, 6 cyclic structures you have to know. So it is cyclo, and always count your carbons first. I didn't follow my rules there, so get your longest chain first, which is propane, and it's cyclopropane. So all I do here is I go in order: cyclobutane, cyclopentane, cyclohexane, cycloheptane, cyclooctane. You should practice drawing these structures. I always tell people if it's cyclopentane or cyclohexane, you're just building peaks. On the cyclohexane, the peaks on the bottom and the top. If you're doing cyclooctane, it's a flat roof, up, across, and down. Same on the bottom, down, across, and up. And then on the cycloheptane, this one's the toughest one because you've got one peaked roof and one flat roof. Practice that, see what you can do. Now, you've got to be able to number carbon chains. So I always say get the longest carbon chain first. That is hexane. It is a cyclostructure, and I put A, B, C, D, E, and F around because I'm going to ask the question, where's the number one carbon on here? And the number one carbon is where you have a functional group. So here you have something coming off. You've got a methyl radical coming off. So it's methyl cyclohexane, and it's 1-methyl cyclohexane. So when we go to the second example, it's a little tougher to see where the first carbon is. But if you take a look at the priority list, what you'll notice is that double bonds take priority over the radicals, over the methyl, ethyl, or propyls. So your first carbon has to be on here. The rule is the first and second carbon have to be on the double bond if it's there. The next rule is lowest numbering. So this could be carbon 1, 2, 3, 4, 5, 6. Here's your other option, and then we're going to come up with the best option. The other option is 1, 2, 3, 4, 5, 6. Remember, the first and second carbon have to be on the double bond in a cyclic structure. So we could go cyclohexene. It's 1 cyclohexene, and then it would be 1, 2, 3, 4 methyl. Now, if we go with the numbers in red, it would still be 1 cyclohexene, but it would be 5 methyl. 1, 2, 3, 4, 5. Which is correct? Well, the correct one is the first one. Why? Because if you add up 4 and 1, you get 5. If you add up 5 and 1, you get 6. Lowest numbering wins. If there's ever a tie, lowest numbering wins. Okay, here we go. Last one. Take a look at that. See if you can find where you think the first carbon is. The first carbon is here. 1, 2, 3, 4, 5. That's overall lowest numbering, taking into account the importance of the double bonds. So that's a cyclohexadiene. There's 2. And where are they? Oh, another way you can do this is cyclodihexene. So as long as you get the di in there, you're good. Okay, and where are they? They are on the first and third carbon, and 5-methyl. So it's 5-methyl 1,3-cyclodihexene. Folks, that is the final video for skills for the day. I'm going to release a project video later today, so for people who want to get onto the unit project, they can.